Welcome to July 6th LeetCode Challenge. Minimum size subarray sum. Given an array of a positive integers num, array of integers num, and a positive integer target, return the minimum length of a subarray whose sum is greater than or equal to the target. If there is no such array, return 0 instead. So we're given a value called target, which is integer, and an array of nums, integers nums as well. And we want to find the minimum length it takes to take the subarray whose sum is greater than or equal to the target. So meaning that if we were to take two numbers at any point in the array, we take the subarray and we want to basically take the sum of the numbers to basically equal or greater than the target. However, we want to take the minimum length to travel between one part of the array to the next. So the target is 7 here, and we will want to basically make 7 or greater by using the smallest amount of movement as possible in the subarray. So if we were to take the values, I guess right here, it's pretty obvious. 4 and 3 makes a total of 7, and you only have to make 2, basically the length is 2 numbers in the array nums to make the target value. Another example here is that you have an array including 4, but your target is 4, so therefore you only need to have one number, which is one subarray equaling the value length of 1. This example here, it's you have array nums here, but the numbers within the subarray, within the array itself, does not equal your target value, so therefore return 0 instead. So the constraint target is between 1 to 10 to the 9. The length of the nums of the array is between 1 to 10 to the 5. Each index value is between 1 to 10 to the 4. We figured out big N linear solution. Try another solution to do n log n. Alright, let's go about solving this. Probably won't do n log n, but so if you want to find a subarray within an array of nums and you want to optimize it, this seems like a sliding window type question, or solution I should say. So intuitively, you want to go through all the subarrays one by one and check the sum of each one. And then if the total subarray is under consideration is larger or equal to the target, then we accept or update our answer as in a variable. And then we just iterate through all of them and define the minimum minimum output, or minimum length of the subarray. So to get all subarray, we could just run 2 loops. The outer loop selecting for a starting point, and the inner loop selecting for the end point. However, if we do that intuitively, it will take basically we have to run 2 loops. It will be running a big O n squared, which is not very good. So a optimization we could do to, I guess, like a sliding window approach is to have a sliding window to achieve 2 pointers left and right, let's call that, and point it to start and ending indices of the subarray, and then we just set the values to 0, then we add all the elements in between, and yeah, that's pretty much it. Instead of just kind of going through the details, let's kind of code it. So sliding window idea typically works by creating a pointer. Let's create a left pointer. Assign that to 0. We also want a right pointer as well. Assign that to 0. And we want to basically find the sum of the current window. So call this sum. Assign that to 0 as well. Next thing you want to do is initialize an integer called result, or output, and we want to basically take the max value integer, so we can assign to any integer max value. Alright. So to do a sliding window, we need to first do a for loop or iterate through our. So for right equal to 0, where the right pointer is less than the length of nums. What we're going to do is we can increment right each time, and when we iterate through, we are able to update the sum to be the compound sum of nums of the right index. So to do that, that's pretty good. And then within this for loop, we want to do a while loop as well. So it's starting to look a little sketchy here in terms of complexity, but it'll work out. So target, well, sum is less than or equal to the target. That's the objective. What we want to do is update our output, and we want to update it to the minimum of what we have so far, and basically the right minus left pointer minus 1, plus 1 I should say, target value. So this is the current index of our window, and we also want to update or decrement the sum with the left pointer. Left pointer minus minus. Because we want actually plus plus, because we want to do the left pointer index plus 1. So we exit this. We exit this again. Now all we have to do is return. What do we return? We return our results. So basically, we want to return our results if it is equal to the maximum value, or if it's equal to our results. So basically meaning that we need to be able to find the condition where we return 0 instead. So say we have an output, and we're going to do a ternary operator here. If that's equal to our the initial value where we initialized to begin with, that means it never got updated. So therefore, there's no minimum subarray, a length subarray whose sum is greater or equal to the target. So that means we need to return 0. Otherwise, it means it has been updated. Therefore, output is the one we want to return. Let's give this a little run. Looks okay. Alright. So the time complexity itself is big O of n, so there is kind of 2 loops here, but the reason it's big O of linear time is because the right pointer can move n times, while the left pointer can also move n times in total. So the inner loop's not really running. It's not running, I should say, in n times after each iteration. So the sliding window can chase a maximum of 2n windows of iteration. So it's also referred to as amortized analysis. Even though the worst case of the iteration of the loop is big O of linear time, it averaged out to basically big O of constant space for this entire thing, the inner loop I should say. Space complexity is big O of constant space, because we're not using any other memory besides the left and right pointers, and the sum, giving value of the sum, and also the output. So we only use 4 variables, integer variables, which take up to constant space each. Alright, have a great day everyone.